Good evening, sir. I'm Mahin Fatima from 3rd CSMB. My digital electronics assignment topic is multiplexers. Let's go into the topic. Multiplexers. First, what is multiplexer? A multiplexer is a combinational logic circuit that selects one of the several input signals and forwards the selected input to a single output line. It acts as many-to-one switch controlled by selection lines. For example, if we have 2 power n data inputs, we'll get one output line and n selection lines. So number of input lines where n is the number of selection lines and n represents the selection lines. So this is the formula 2 power n. A multiplexer is also known as data selector because it selects one of the many inputs and routes it to the one output based on binary value of the selected input. Next, how does this multiplexer work? Multiplexer uses selection lines to choose which input is connected to the output. The binary combination on the select lines acts as address that points to the desired input channel. Let's say we have inputs from I0 to IN-1 data lines carrying the signals. Next we have selection lines. It is from S0 to Sk-1 control lines that select the active input and one output line, the forwarded signal from the chosen input. Input stage, multiple data signals are applied simultaneously to the input lines. Selection logic and gates evaluate the selection line combination and enable the correct input. OR gate output. All AND gate outputs feed that, producing the final selection line. Next, we have various multiplexers. First one is 2x1 multiplexer. 2x1 multiplexer is also called as simplest selector. It is the most basic form, selecting between two input lines using a single select line and routing the chosen input to one output. Let's say we have inputs, two data inputs, and we have one selection line and one output line. So the gates required for this construction of this multiplexer is two AND gates, one OR gate plus one NOR gate. As we can see in the block diagram here, we have two input lines and one output, one selection line. This is the truth table. And key applications: basic signal routing in ALUs, building block for larger MUs, single bit selection, simple watching circuits. So next one is 4x1 multiplexer. In 4x1 multiplexer, we have 4 inputs, 2 selection lines and 1 output. So the structure is like this. We have this is the block diagram. This is the block diagram of 4x1 multiplexer, 2 selection lines and one output line. So Boolean expression can be written as S1 S0 I0 plus S1 S0 dash and I dash plus S1 S0 and I dash. Here minterms uniquely selects the one input based on the combination of two selection lines. This is the truth table. So next we'll go to 8x1 multiplexer. In 8x1 multiplexer, we have 8 inputs, 3 selection lines and 1 output. So this is the block diagram as you can see in this slide. All these 3 selection lines are passed through these AND gates, 8 AND gates, and we have this final output gate AND gate. 8 selection lines, 3 select lines and 1 output line. So we have total 2 power 3 combinations, 8 unique selectors. Next one is 16x1 multiplexer. It is the maximum scale. We have 4 selection lines and 16 input lines, data inputs, and one output line. And this is the truth table of 6x1 multiplexer, 4 selection lines and one output line. As you can see in this block diagram, all the input lines are passed from the NOT gate and AND gate, and finally the result is OR gate Z. So next, this is the function and the truth tables of these types of multiplexers. This is the truth table of 2x1 multiplexer. We have one selection line, one output line and one input line. Whereas this 4x1 multiplexer, we have two selection lines, one output and four output lines. This is the 8x1 multiplexer truth table. Next, advantages of using multiplexers. So there are many advantages of these multiplexers. Like first one is reduced wiring. Transmitting multiple signals over a single line drastically reduces the number of wires and interconnections needed in complex systems, and it also reduces cost efficiency. Low material cost, reduced PCB complexity, and we have high speed. It is versatility, compact design, and scalability. So the main idea of multiplexers is to reduce the complexity and reduce the cost. This is all about multiplexers in digital electronics. Thank you for giving me this opportunity. I hope you found this session insightful. Have a nice day.